that the evaporation rate of the natural bodies of water in the area was only 392 gallons per day. This was barely enough to create even a light fog, let alone the dense, thick fog described by accident victims and rescue personnel. Eschenroder was convinced there had to be another source of water vapor which caused the thick fog. He noticed a series of ponds which straddled the interstate highway on two sides. These were wastewater treatment ponds which belonged to the Bowater paper plant. These ponds were used to clean the industrial wastewater from the paper mill. In two of the ponds, aerator fans would propel the water up into the air. Most of the water dropped back into the ponds. Some of it did not.
That's called drift. Drift droplets are things that drift away from the site of where they are formed. All the other droplets fall back to earth or fall back to the pond where they originate. So we had to do some original calculations in an engineering estimate fashion for emission of those droplets.
Eschenroder calculated that these wastewater treatment ponds added 10 million gallons of water vapor into the atmosphere in the 24 hours preceding the accident. Far more than the 392 gallons from the natural bodies of water. At the paper plant itself, an additional 1.5 million gallons of water vapor was being released each day from the smokestacks. But it wasn't just water vapor that was being released from these smokestacks. Paper plants released what are called particulates as waste from the paper production process. Particulates are microscopic particles which become surfaces on which water vapor can condense, and this leads to fog.
You not only had the fog potential from the presence of the water vapor, but you had a place for it to form in the surfaces of these microparticles, these condensation nuclei.
But how could Eschenroder tell if the water vapor from the Bowater paper plant 3 miles away caused the fog on the interstate highway on the day of the accident? He found part of the answer on this aerial videotape shot by a local videographer a few hours after the accident. Eschenroder recognized the wind pattern as a drainage flow which carries cooler air down into the valley. But Eschenroder needed to know in which direction the drainage flow was heading. To do that, he needed to know the exact position of the airplane. Using navigational charts, calculating the position of the sun from the glint angle off the wing and ground references, he identified the plane's position relative to the paper mill and the accident site. The videotape convinced Eschenroder that the drainage flow wind pattern was headed west from the location of the paper mill towards the accident site.
Something about photographic proof like that to me beats an awful lot of analysis and wind modeling.
All of this information was put into the InPuff computer program. It's a program that predicts the impact of